All right, so rationals is what we're going to talk about tonight. And they have been kind of talking. Remember, we were doing some rational stuff in the very, very beginning, and I kept saying, we're going to do this later. We're going to do this later, so this is later. A rational, all right, a very simple rational is just going to look like this, where you have 1 over x. So anytime you have like a fractional situation where the x is in the bottom, that's a rational. Okay, so this is a rational function. This is in its very simplest form. The real key behind rationals is that you cannot have a 0 down here. So x cannot be 0 in this case. So the denominator of a rational cannot be 0 because it doesn't exist, right? So that is the big idea for all of the rational stuff that we do. All right, that the denominator cannot be 0. All right, so no matter what the rational is, all right, whether it's like this, okay, or something like this, whatever it is, okay, it cannot be 0. So x, whatever you have down here, this whatever x is, you can't make sure you get a 0 down there. It's undefined. So that would be the issue. All right. You can have a rational with an x on the top, something like that. That's okay. That's okay. But what makes it rational is that x on the bottom. All right. So that's what rationals are. Let's do this though. Let's jump into Desmos, and I'm going to go ahead and send you my. This is going to be my high school account. Okay, so it's kind of long. All right, so at .k12.or.us. So that is the username or the email. It's going to ask you.
Can I just clarify?
Sure.
So you said that there can't be an x. So the first two that you wrote, where it's x plus 1 and then x squared minus 1, you're saying that those cannot be rationals, correct?
Those are rationals. What I'm saying is that this bottom part can't be 0.
Okay, for those problems. But for the third problem there, it's okay because the x is on top?
You still can't have a 0 in the bottom of a fraction. It's undefined.
Okay, thank you.
Yep.
Okay.
And the password is the same as it is with PCC. So that's what you want. It's rogerp@sthelens.k12.or.us. And the email that's the email. The password is patmath. So I'm going to make my way there. I'm going to get rid of this guy. Oops, I don't need it. Give me a new one. And I want to make sure I'm signed into the right one. Okay, I am. So I'm going to stop sharing this screen. Okay, and start sharing this screen, but not for very long. All right, and let's see. I just want to come down here and make sure I have so much stuff in here. Let's see, what do we got? What am I looking for? PC? No, there it is. I want this one. So I'm going to put this into the chat so you can see it. You're looking for PC rats. Only I have this. My other math teachers always laugh at my name and titles. And I think it comes from the days of when I first started teaching. I'm going to really date myself on this. We used computers that used MS-DOS, and it was a very very particular operating system, and you couldn't use spaces to title things. You couldn't use symbols. Everything had to run together, and so that's how I learned to do things. And to this day, I hardly put anything in my stuff that I keep it kind of like that. So yeah, that's where I get that from. I don't know if any of you have ever heard of MS DOS before, but I can tell you some stories about some of that stuff. So I'm going to kind of wait for you to pull that up. And pretty soon I'm going to quit sharing so you can actually play around with this a little bit. Is there anybody that doesn't have this? Just send me a private chat if you don't. Okay, so I guess everybody has it. So basically what we're going to do is, here's our folders, right, that I was talking about. So if you click this, you're going to get some stuff here. And it says, what do you notice about this graph? Be sure to slide A. So you want to click on the graph first, all right, and then you're going to slide A. All right, now this is our typical rational function. Now I'm not looking for anything sophisticated here. I just want you to kind of notice some stuff about what happens when we slide things. When you're, and you can record it if you want. You can write it down someplace if you want to, or you can just put it in. You guys all have young brains with lots of memory, so you can store things in there. Once you're done with that one, click off of the red one and close that question and go to question number 2, and then so forth. All right, so I'm going to quit sharing, and when do we do this? So yeah, go ahead and work with this for a little while. Let's say about 3 minutes or so. It'll be a tad bit after 7. Then we'll review it, and then we'll take our break. All right, so let's do that. Yes, you're okay. All right. No. All right. So I'm really interested in some of the things that you came up with. So I'm just going to go to question number one here, and I have mine on, but I'm not going to share it. So you can either tell me or you can chat with everyone. Let's share with everyone. Um, and again, just give me some ideas of what you noticed. So, what did you notice about the first one when you slid A? What did we notice about the graph? What are some things?
Do you want us to type them, or can we just?
I don't care.
Oh, I was gonna say it moves horizontally.
Okay, it moves horizontally. I see somebody else made that same comment. Moves right and left. Okay. What about the graph itself? What are you noticing about that?
At -2, it's just a horizontal line. I believe.
If I put a negative where?
At -2, the slider.
Oh, I'm gonna go check that out.
I think it does.
Now, hang on. Are you talking about the first question or the second one?
The first one.
Because when I go to -2, I don't get a
Oh,
horizontal.
wait. I might be talking about the second one.
I think you are. So hold on to that comment. That's a good one.
Sorry.
That's all right. That's a good one. Just hang on to it. All right. What about what about number one? What about the shape of the graph? What's that? How would you describe that? It stays constant. Good. All right. What else? Is it curved? No
Do you just
count.
mean in general? Oh, do you just mean in general, or as we
Yeah,
move this?
sure. Is it curved?
Yes.
Yes, definitely. Okay. What else about it? There's one thing that sets this one apart from any other graphic. Well, not any other. I will take that back, but for sure the polynomial graphs.
Is it the double asymptotes?
Okay. Well, I wasn't even going to get that complicated, Spencer. I was just going to keep it so we didn't even know what asymptotes really are. But yeah, that's exactly what's happening. Okay. So we're getting what's happened is that we are getting a curve, but this graph we would say is discontinuous because when I try to trace it with a pen or pencil, right, I have to physically lift it up to trace the other half of it. Okay. So when you have to physically lift up your pen or pencil to trace it, that means it's a discontinuous graph. And we've had a few of those, but I don't know if we've ever used that word. So all of the functions that we did with polynomials, square roots, absolute value, logs, all continuous. Every single one. But this one's not. Okay. So I'm going to just share this real quick because I want to use some of this terminology here. And then we're going to answer these other questions and then you get your little break. So look at this here. Yeah, I know. Get rid of that. This graph curves upward drastically, right? Drastically curves upward, drastically curves downward, okay? Does that curving action happen at any particular point as I click on this and play it? Where's that happening at?
Around A.
Around A, right? Okay, right around A. That's the A that's on the bottom here, all right? So yeah, that's what's happening. So we're getting this discontinuous curve, right, at this value of A, right? Okay, cool. All right, so I'm going to stop sharing again, and I want to get rid of this. I want to go to question number 2, all right? And somebody said already on question number 2 that at some point we got a horizontal line, okay? And they said -2. So it kind of depends on where your values are at. So what values of, so tell me some stuff about that horizontal line. When did that happen? Anybody notice that?
It's when both B and C are identical.
It's when B and C are identical. Okay? It's when B and C are identical. That's the way we get a horizontal line. All right, so now I'm going to go back to this. So it's when this B and C are identical. Mine are both -1. But here's the kicker. So when I go to this and I trace around here and I'm going to get real close to -1, right there, right there, okay? It tells me that that graph is undefined. And it even puts a little tiny hole in there. So when these things are both the same, then you would think, wouldn't they just cancel out? So in other words, wouldn't this just be x plus 1 over x plus 1? And then why don't they just cancel out and give me 1? Because that's what would normally happen if we had 3 over 3, right? So why doesn't that happen? Why don't we just get 1? Any ideas? We're not a real talkative group here tonight, so let's see. The reason is because it goes back to this idea where, right, we can't have x be a -1, okay? Because if I have x be a -1, I'm going to get a 0 down here. Can't have 0 down there, right? That's what we can't have that. It's undefined. So because this x equals -1 is the only time that I get this sort of situation, right, when these two things are both the same, that's why it doesn't work that you can just cancel them, okay? So what does occur is what we call a hole, okay? Now the book doesn't really get into holes very much. I don't know why they don't, because they do come up. So here we have a hole, all right, at -1. So if we were to trace on this, it's actually a discontinuous graph, because right there, I got to jump over it to get in there. So it's kind of like a mud puddle of some sort. You don't want to get your feet in the mud, so then you got to jump over it or hop over it or step over it, okay? But it's not continuous. And it doesn't really matter if I go to -2 here and -2 here, right? I'm still getting that hole. Now, any other time, I'm fine, right? Because they're not the same, as Spencer says. So I hope you kind of get that, because that's kind of a pretty important idea, that you would think this would cancel out, but it doesn't, because of the idea that you can't have 0 on the bottom there. All right. Question number 3. Now, there's an interesting one. Any ideas on that? What's happening with that one?
I was noticing it. You were able to get kind of like 3 separate pieces at certain values.
Yeah, you get 3 separate pieces, right? Exactly. That's what's happening there. All right. You can have 3 separate pieces. You can have 2 separate pieces, right? I mean, if you played around with it enough, you could probably get that horizontal line. So there's a lot of stuff that can happen in that particular situation. All right. So it's kind of a neat little exercise in introduction to rationals and what they do. All right. So it's 7:14. Let's come back at about 7:25. That's a nice even number. And we'll do some, we'll just kind of write some stuff out, okay? And then we can start going from there, all right? So let's come back, 7:25.
Mr. Patterson, I had a question, if you don't mind.
Hang on here. No, I don't. Go ahead.
So you were saying that most of the polynomials that we've worked with are, I guess, continuous. Like they're just one solid piece. Would this rational function be close to, I guess, like a piecewise, even though it's not technically multiple like pieces? It's all one like equation. And I had a similar question about, I guess, like the floor, or the was it the floor, the step function? I don't remember the exact word for it. It has kind of a similar thing going on where it jumps.
Yeah, so you got some good questions. So the first one you're saying is a rational, sort of like a piecewise. I'm going to say no, because I'm going to say they're different in that a rational has an undefinedness to it.
Okay.
And a piecewise is just defined at values that you know, on your conditionals, kind of, where you're saying, hey, it follows this rule between -2 and 0, but then it follows a different rule between 0 and 3, and so forth. So that one's
because the rational is following the rule the entire way through. It just happens to be undefined at one point.
Yes,
that would be the differential. Okay.
That's how I would say that. The floor, ceiling, and the round that we looked at, those are considered like step functions, and again, they're not. They are discontinuous, and so piecewise functions can also be discontinuous. They do fall into that category, but that's the only thing they would have in common with the rationals. They're just separate types of functions.
Okay. Thank you.
Mm-hmm. All right, I was responding here, so I was responding, so it took me a little bit. Let me go ahead and share screen here a little bit and let you